stage, we're going to have a look at the raycasting algorithm. We won't worry about 3D rendering yet, as there's a lot of benefit to just understanding the algorithm itself. One of the challenges of raycasting is that it's such a simple idea in theory. We have a 2D array. Zeros represent empty space, and any other number represents a wall. We look from the player's position and step forwards until we hit a wall. To help us work out our position, we have the line equation. It basically states that we start at some position and then look out from there in some direction. So then this idea of stepping forward basically involves slowly incrementing the value of t until the ray position is sampling a wall. But the devil's in the details. If we take large steps, we risk completely missing walls. And on the other hand, if we take smaller steps, we can waste a lot of time walking through empty space. In this stage, we'll solve this problem by using an adaptive step size method called digital differential analysis, or DDA for short. If we look at this image, the ray is starting from the player's position, traveling to the right and upwards. At every step, we must decide whether to step forwards far enough to move us one grid square to the right, or far enough to move us one grid square upwards. How do we decide this? Well, the simple answer is we take whichever of those two steps is smaller. In order to make these sorts of decisions, we need to know how far forwards a step will take us. Here, dist x is the forwards difference along the ray necessary in order to change the ray's x coordinate by 1, and likewise for dist y. Calculation of these quantities can be made by similarity of triangles. The top left triangle represents a ray in its natural environment. The ray's direction has some length and can decompose into components. The hypotenuse of the triangle represents how far the ray will step forward. So by dividing all sides, we can solve for the case where we step forwards by 1 in the x or y axis. Since both expressions have a common factor, and these distances are used as decision parameters, we can divide out the common factor to simplify things. We can also deal just with absolute values, since it's distances we're interested in. These decision parameters are fine once the ray is locked onto the grid, but what about its starting position? Turns out this is fairly straightforward once we know dist x and dist y. The player starts at some fraction of a grid space away from the grid lines. We just need to calculate how far the ray will need to step forward to get to the next x or y grid line in the direction it's looking. And so finally, here's the basic algorithm. We start off by initializing the state of our ray, and then we continually decide whether to step to the next x or y grid line. And after stepping, we check whether the map position that the ray is on is blocking. If it is, then we're done. If not, then we keep walking. You might be noting along the way that we're tracking two distances. Why is this necessary? Basically, decisions are based on whole grid steps. If a whole y step takes the ray part way across into x, then it's difficult to make a proper x decision from that point. Today we looked at the underlying logic of the algorithm, but we can still code something up to show it in practice. Let's say we want our top-down view to show a single raycast along our forwards vector. First, we'll get the player's position on the grid. We'll then get the components of the ray's direction. In this case, the ray will be looking along the player's forwards vector. Once we have the components, we can calculate dist x and dist y. We can then calculate the ray's initial distances and the direction that it will step in when it decides to step in the x or y grid. To test the method, we can draw the player's current position. Finally, we can start stepping the ray forwards, stopping when we hit a wall. And that's it. In the next stage, we'll apply this to a larger scale and render a 3D view of the world. I hope to see you there. All the best. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.